I wanted to start with this slide set here because the question was asked after Dr. Gilliam's talk just right before lunch about, is there an interaction between metaphylaxis and vaccination? And we looked at that exact question with this study here, where half the cattle got Draxxin on arrival, half the cattle got vaccinated with titanium 5 on day 0 and revac on day 14. So there was those two main effects, but then some of the cattle didn't get either. Some of them only got vaccination, some of them only got antimicrobial metaphylaxis. And essentially, really quick, we saw huge differences in health if the cattle got metaphylaxis. So these two groups would have gotten Draxxin. The group shaded in yellow got Draxxin on arrival, and you can see their morbidity was somewhere 21% morbidity or less. If they didn't get Draxxin, 50% morbidity. So we often say that metaphylaxis reduces morbidity and mortality by about half, and that's about what we saw in this study. However, if you look at the vaccine, if they got a vaccine or did not, the vaccine did not impact health really at all. And that is shown here. So in the yellow bar, those are the cattle that got vaccinated. In the red bar, those are the cattle that did not get vaccinated. And you can see the percentage of morbidity for first, second, third, and fourth treatment. Really no difference. So this kind of leads me into the talk that I'm going to give today, linking calf health to feed yard performance. Dana came up with that title and did a great job of coming up with a title, and I'm going to talk a little bit about why health relates to performance. It certainly does. I'm going to bait and switch a little bit and talk and kind of continue on a little bit of what Dr. Gilliam talked about with vaccine efficacy in these high-risk stocker calves, and also talk to you about some metaphylaxis things, and then as well as some technology that's coming down the pike that may help us manage health in like high-risk stocker and feedlot cattle. So BRD, this disease we've been discussing, it's a decades-old challenge, 50 or 60 years old, influenced by the antiquated calf marketing system, widespread viral exposure, and otherwise commensal bacteria. That sums up this disease in one sentence, is that it's extremely complicated. It involves lots of different factors. And to me, we focus on the pathogens a lot for good reason, but stress-induced immunosuppression is huge in this disease. And I think we're starting to really pay attention to that factor of bovine respiratory disease. And that's kind of what my talk will be centered around. We'll talk about arrival processing procedures, a concept called targeted metaphylaxis, and then I'll talk about new technology and some of my thoughts on vaccination of high-risk calves. So here's where our beef cows are in the US, and they're pretty much spread from coast to coast, right? We definitely have congregation through the high plains. We've got a lot of cattle in the southeast, but we have cows all across the coast. So this is where the cows are, right? So this is where the calves are coming from. When we look at our cattle feeding operations, very different looking map, right? We are congregated in the high plains of Texas, western Kansas, and then up through the Midwest a little bit. And so the challenge is we've got to move these calves from their ranch of origin to our stocker operation or a cattle or a finishing operation. And there's a lot of challenges with doing that. On the map, I kind of indicate red dots of being like perhaps a sale barn, right? Where an order buyer, represented by the yellow dot, may purchase cattle one at a time, like was discussed earlier, take take those calves to the order buyer facility until they finally get a 100 head truckload lot to send on. And through that process, it's very stressful on calves. I'll walk you through the journey of a high-risk calf here. So if I'm a small cow-calf producer and I'm not utilizing preconditioning whatsoever, I'm probably going to separate my calves from the dam, straight off the dam, right? Let's say on a Tuesday morning. I take that calf to the auction market later that afternoon. That calf is handled and sold at the auction market, let's say on a Wednesday. And as soon as that calf goes to that environment, it's like the daycare, right? Like Dr. Gilliam mentioned. And there's probably viral transmission that can potentially start at that point. It's commingled with other calves onto a truck on a Thursday at that order buyer facility, because we're not going to ship half of a semi-load, right? Because shipping is too expensive. So we're going to put together 100 calves, and the high-risk calf, the calves that I get, probably 80 to 90 sources on a 100 head truckload. We've looked back at sale barn tags, and that's how many sources these calves are coming from. So they're transported to the order buyer facility on a Thursday, maybe commingled again there, transported to the feedlot, oftentimes overnight. I have that asterisk because does anybody ship calves overnight or have calves shipped to them overnight? Usually in the summer, because we feel like it mitigates heat stress a little bit, which I think is a good thing in the summertime. In the winter, I don't know, not so much, because if we're shipping these calves on a truck overnight, what are they doing? We've done research to look at animal behavior on a truck, and they're standing the whole time unless something's wrong, right? So they're not bedding down and resting like they're used to doing when the sun goes down. And when we ship them overnight on a truck, there's a thing called the circadian rhythm. And we see this all the time. If we stay up really late or interrupt our sleeping pattern, it's very stressful. So I think we might be contributing to stress by doing this. Now, very hot situations, it's probably worth it. Through the fall and winter, maybe not. We unload these calves in a novel environment on a Friday morning, and then we typically process them the next day after about 24 hours. I'll talk more about that. And it's no wonder that we have a BRD outbreak, because these calves are chronically stressed, and we know stress causes major immunosuppression through lots of different mechanisms. This process started on a Tuesday morning, and we're not processing these calves until Saturday. So you see the journey these high-risk calves go through to get to our operations. I mentioned how complex this disease is, and there's a lot of different infectious agents, but physiological stress is extremely important. Cortisol is produced in response to stressors, and cortisol does certain things to the immune system. Namely, it interacts with white blood cells, right? And white blood cells, or leukocytes, are very important for the immune response, and makes white blood cells not as active or able to find infected tissue as well. So that's how stress really causes immunosuppression. When does this disease occur? It occurs typically in these high-risk calves very quickly, right? So this is a morbidity curve across time, and it's showing cumulative morbidity. And in this particular set of calves, by day 14, we're pretty much almost done treating calves initially for this disease. Now there's probably retreats that carry on, but we typically see morbidity very quickly because of that process and the stress and the pathogenic exposure that occurs through the marketing process. The good news is yeah, there's a very effective management strategy, right, to mitigate this challenge in calves, and that's called preconditioning, right? Preconditioning essentially instead of lumping all those stressors into 4 or 5 days, right? Preconditioning is a way just to kind of spread them out so we don't hopefully induce chronic stress. Because we still have to ship preconditioned calves, right? From the ranch to the stocker facility or to the feedlot. But they're not undergoing other stressors like weaning, castration, etc., all lumped in together like these high-risk calves experience. This is the percentage of cow-calf operations that vaccinated calves against respiratory disease specifically prior to sale. And similar trends here, but I use this data to tell me how many of our calves are coming to market that are preconditioned versus how many calves are coming to market as high risk. Because if everybody agree that vaccination is a major requirement, right, for preconditioning. And so if they're not vaccinated, I'm going to assume that they're a high risk calf, okay? And across all operations, at least, it obviously it increases as the operation size gets bigger, but across all operations, only about 40% of all operations vaccinate against respiratory disease prior to sale. So I use about 50% probably of all cattle are being marketed in a high risk manner, okay? What do we do when these calves arrive? We typically give about 24 to 48 hours rest. Why do we do that? If we ship calves medium or long distance, why do we give them rest before we process them? Anybody know? What?
It makes us feel better.
Makes us feel better, right? Stress. That's the very common answer, but I would argue that they're probably more stressed physiologically 24 to 48 hours after we get them than they are when they show up. Now, they may be less dehydrated. They may have a belly full of hay after 24 hours, but they're still very, very stressed 24 to 48 hours. In fact, that physiological stress is probably peaking about that time, okay? And so we need to think about physiological stress when we process cattle and what the products we give, how stress may interact with those. And we'll talk about that. That I'm aware of, zero research says you should wait 24 to 48 hours to process cattle. It's just something we've done. It's become part of the paradigm. And I think we need to look at this. Are we really getting a benefit? Are we changing outcome of health and performance by waiting a day or so to process? Okay. Definitely give these creatures hay and water though, right off the truck. A lot of feed yards are kind of guilty of this, but stocker people hopefully do a better job of this. But yeah, they're dehydrated, they're shrunk. Give them hay and water right off the truck. Here is a real processing order from a consulting veterinarian in our area. But this is what they are giving high-risk calves off the truck. They were giving a trivalent MLV respiratory vaccine, modified live, an autogenous manhymia, an intranasal modified live respiratory vaccine. If they were bulls, they were getting clostridial. They got metaphylaxis, they got a dewormer, they got a growth implant. Sometimes they would give an injectable trace mineral. Sometimes they would give an immunostimulant or Zelnate. They'd castrate them if they were bulls. They'd dehorn them if they had horns. All of these at this particular feed yard got branded, and then they got an ear tag. My point is, that is a hell of a lot of stuff we're doing to calves that have gone through the journey I shared with you, right? A lot of these things that we do are very inflammatory. A lot of them can actually contribute to physiological stress. Some may be efficacious, some may not. One thing that is very efficacious, in my opinion, and research supports this, is antimicrobial metaphylaxis. You guys know all about this if you've gotten high-risk cattle in. You see the definition. It's the timely mass medication of a group of animals to minimize an expected outbreak of disease. Almost every feed yard uses metaphylaxis, and then we implement a PMI, or a post-metaphylactic interval, that is a really helpful management tool, right? If you're able to get a load of calves in, give them Draxxin or Zuprevo or Zactran or Micatil, it buys you some time, right, before you have to get in and start pulling and treating those calves. And to me, when I get high-risk calves in, there's just a lot of value in that. It lets me breathe for a minute on that particular lot load and know that I don't got to get into them right away and start pulling and treating cattle. And to me, this is my opinion, but of all those things that we listed that we do at initial processing, this is the only thing we do that has repeatedly shown to improve health and performance in high-risk calves. Okay? Not vaccination, maybe not an anthelmintic. An implant probably helps with growth performance, but doesn't directly probably impact health. And so metaphylaxis is the major tool we have in our toolbox to help with health. But I mentioned targeted metaphylaxis earlier, right? And targeted metaphylaxis is a new approach. It's an alternative way to give metaphylaxis that, instead of at the population level, where we assess a truckload or assess an entire pen of calves and call them high risk and give the entire group a metaphylactic drug, we determine this on an individual animal basis based on certain metrics that may indicate that that individual animal within the high-risk truckload may be at very high risk for subsequent BRD, okay? And I'll go through some of those factors. This is important to understand. So Mike Apley, several years ago, took literature of studies that had a metaphylactic treatment and a control, and summarized all those studies with various drugs, right? So this isn't all just Draxxin or all just Zuprevo, and they're kind of older studies, so some of those newer drugs aren't in this. But they calculated a number called number needed to treat, NNT. Number needed to treat tells me how many calves have to come through my chute that I give metaphylaxis to make a true impact in one calf, okay? So if my number needed to treat is 2, then every other calf that comes through my chute is benefiting from metaphylaxis. If my number needed to treat is 10, then I have to treat or give metaphylaxis to 10 animals to make a difference in one animal in that particular population group. And he summarized this across all these studies and found that the average is 5, okay? So so I have to treat 5 animals through my chute to make a difference in one with metaphylaxis. Another way to look at that is on a 100 head truckload, only about 20 head in that truckload truly benefit from metaphylaxis, okay? Now that's probably a little higher than what it actually is, because some of these are less effective antimicrobials in the study population, but it's somewhere close to that. We know that if we got a load of high-risk calves in, yes, we have some of those train wrecks where we may treat almost all of them, but most of them, we're not going to treat every single animal in that truckload. And had we not given metaphylaxis, there's a proportion of animals that would have remained healthy and probably wouldn't benefit from the drug, okay? So targeted metaphylaxis essentially is trying to find those 20 animals that truly need the drug during processing, right? And so if we implement a method like that, what are some things that it needs to be? It needs to be very rapid, right? So we process cattle pretty quickly. It needs to be accurate. It needs to be cost effective, right? It can't cost us $50 a head to do this. But if we can find those, let's say it's 50 out of 100 benefit, right? And we implement targeted metaphylaxis and we find the 50 that truly need Draxxin, how much money am I saving? If, let's say they're full weight cattle and we're putting a $20 Draxxin shot into each animal that gets it, if I go from 100 animals getting Draxxin down to the 50 that really need it, how much money am I saving? Saving $1,000 on that truckload or $10 a head, right? So there's an instant savings potential to the producer by using targeted metaphylaxis. The test may cost me something, and it has to cost somewhere less than $10, right? But there's a potential cost savings. Why else consider targeted metaphylaxis? Everybody knows by now, right, that the consumer's asking for less antimicrobial use, right, in cattle. And I worry that the consumer may not like mass medication very much, even though it's highly effective, and I would hate to lose that tool. But this would be a way to hopefully keep that management practice, but then go back to the consumer and say, hey, consumer, here's what we've done to reduce or more judiciously use antimicrobials in our industry. We're actually doing a test to try to find the cattle that we think are at greater risk for disease. So there's 7 different metrics that I'll go through fairly quickly that may help us identify at the individual animal level during processing which of those individual animals may be at greater risk for disease. And this helps you think about targeted metaphylaxis, but it also helps you think about this is why calves get sick, or this relates to why my calves may get sick with BRD. First one is chute entry order. If there was some sort of repeatable pattern, if I got a truckload of high-risk calves in and I turn them out in the alley and it's pretty much random, right? When I turn them out and then I just go and peel off a portion of them, bring them up to the chute. If there was some sort of pattern, right, of how, the order that they went through the chute, let's say kind of our theory on this was maybe the last 20 head on a 100 head truckload have much greater morbidity because they were back at the pack or something like that. But maybe the last 20 head get much more sick than the rest of them, or maybe the first 20 head. We looked at on about 1,000 head based on if they're the first 10, first 20, 30, 40, all the way to the end, 90 to the 100th entry out of 100 head, and what their BRD rate was, if you will. There's about 100 head in each of these bars, and no real pattern, unfortunately, in this data set anyway. Okay, so probably not a good tool. What about bulls versus steers at arrival? We've done research that suggests that bulls are over 3 times more likely to be treated for BRD than steers. And we can easily tell at the chute, right, if it's a bull or a steer. And so this may be a metric to better target metaphylaxis. Why do bulls get treated more often for BRD than steers? Well, what do we do when we process bulls? We castrate them, right? And so castration is painful and inflammatory. And depending on how we castrate, we can have an infectious complication, and castration probably predisposes animals to BRD. But if I buy a truckload of high-risk calves and it's a steer, right? What do I know about that animal? It's been in the chute at least one time before it arrived at my place, right? And so if it's been in the chute at least one time at the ranch origin and was castrated, hopefully it was vaccinated maybe. It was probably received a better nutrition or mineral program. It probably is a proxy for management, right? And that's what this next item suggests as well. When you buy high-risk calves from an auction barn, at least the ones I get, we buy a lot of our high-risk calves from Capital. Capital Land and Livestock is, I think, the largest order buyer in the nation. They're in Central Texas, just north of Austin, and they buy out of all over East Texas, out of McAllister, Southern Arkansas, Louisiana. And about 20% of the cattle that I buy from them show up with a ranch tag in their ear. Okay? What does that tell me? They've been through the chute, at least unless they're really good at tagging, unless they tagged them at birth, right? Or they are really good at tagging calves. It's probably been through the chute at least one time, which is a proxy for management, right? In fact, we have started to document this in all the high-risk calves that we receive. And we are taking a look at if they show up with a ranch tag in their ear, here is what their performance is versus those that do not show up with a ranch tag. Look how much more body weight, how much higher the average daily gain is. And then here's the morbidity if they show up with a ranch tag or if they don't. Almost not quite twice as much morbidity, but significantly more BRD treatment in calves showing up with clean ears versus those that have at least a ranch tag or a fly tag in their ear. Some of them just show up with a fly tag. Okay. Another proxy to help me differentiate more within an individual animal basis which animal I might want to give Draxxin to. Body weight is always, we've long known that within a truckload lot, the lighter cattle in that truck are probably more susceptible to respiratory disease. And indeed, this is from a study we did a few years ago, but here's the morbidity rate of calves within a truckload lot that were the lightest 25%, intermediate, and the heaviest 75%. And you see their morbidity rate goes down as they get heavier within that truck. Why is that? Those heavier cattle may be a little older, right, and have a more mature immune system. They may just be thriftier, stronger animals. There's a lot of different explanations for that. Rectal temperature is another thing we can do, chute side, that's fairly quick, that almost everybody has a thermometer if you're dealing with high-risk calves, right? And we can measure rectal temperature and give metaphylaxis discriminately or in a targeted manner. Let's say if an animal has a fever. And that's what this study looked at. They had a control group, and this was with Micatil, and this was done back in the mid-90s when Micatil worked really well. It still works good, but it doesn't work as good as it did in the 90s. Why not? Micatil came out in, I think, 93. It was an awesome drug and still is a good drug, but I think most would agree doesn't work as good as it used to. Why not? We've used Micatil on a lot of cattle, right? And metaphylactically as well. And everybody's heard of antimicrobial resistance, right? It started out as, oh, we're questionable about it, but I really think we're seeing resistance of the bacteria that we're trying to target with antimicrobials in cattle, Mannheimia hemolytica, Pasteurella multocida, to a degree Histophilus somni. It's popping up a lot more further south. We're creating resistance, and by using these drugs, it's just a natural biological process. None of the cattle got metaphylaxis with Micotil. Here's their morbidity rate. Here's their gain. All of the cattle got metaphylaxis with Micotil. Here's their morbidity rate. Here's their gain. A third treatment group that got metaphylaxis with Micotil if they had a rectal temperature greater than 1035. And 42% of that group had that rectal temperature greater than 1035. And here's their morbidity and their performance. Was there a difference if all of them got metaphylaxis versus if 42% of them did based on the rectal temp? No difference in health, no difference in performance. If this is repeatable, which I'm not sure it is because there's other research that suggests rectal temperatures kind of all over the place as far as predicting BRD. But if this is repeatable, shame on us, right? Shame on you if you've been using metaphylaxis, because you could have just been rectal temping those calves and cut your metaphylactic cost in half and had the same health and performance. And we could have used a lot less drug over the last 20 years. Not sure if this is repeatable though. And one challenge with doing this is, what is clear, especially when temperatures are fairly hot, the later you go in the day and the later in the processing order, the higher the rectal temperature average gets. And so a calf that enters the chute first is going to have a lower rectal temperature than a calf that enters the chute last. And so there's some confoundment there with rectal temperature and what the ambient temperature might be. Lung auscultation. Anybody heard of the whisper scope or tried it? Doesn't work very well, in my opinion. Okay, they're trying to make some improvements with the technology. They've funded some studies to try to target metaphylaxis based on what the whisper scope says. Didn't turn out very good, okay, for a lot of reasons, and I won't get into it. If you have questions, ask me. The last variable would be like biomarker-assisted variables. So we take a blood sample, and what is in the blood that may tell us if an animal's more likely to get sick? There's lots of different things we can look at related to this. One is called haptoglobin. It's an acute phase protein. It tells us how much inflammation there is in an individual animal. The problem with haptoglobin is you can see this is a time course here and the haptoglobin response, and it's extremely rapid, acute, and doesn't last very long. So I don't think this would be a very good tool to use, because depending on when you measure it, you're probably going to miss a lot of this peak haptoglobin response occurring. Another blood variable is called NEFA, or non-esterified fatty acid. And the dairies use NEFA a lot in like transition dairy cows to tell them, what does NEFA tell you? Does anybody know what non-esterified fatty acids in the blood may indicate in a bovine or may indicate in you as well? Ketosis, yeah. And ketosis is largely driven by negative energy balance. And so if we are not eating enough nutrients, right, to maintain our body functions, what does our body do? Our body undergoes lipolysis, and it breaks down our fat stores to provide our brain glucose and provide our body energy. And so we can measure how much lipolysis is occurring in an animal by measuring the NEFA concentration. This may be a good tool. In fact, you can see how high the NEFA concentration is. And these are in high-risk calves when we collected blood at day 0, day 14, 28, and 42. Look how high the NEFA concentration is at arrival. Why is that? Those calves have just gone through that marketing process, right? And have not been eating or drinking appropriately probably for several days. And therefore, they're undergoing lipolysis, breaking down their fat to provide their body energy. We're starting to look at nasal or different microbiomes. You guys have probably read about microbiome in a magazine or somewhere else. And this is just quantifying the bacterial population in a culture independent manner, and helps us to understand relationships with bacterial communities, etc. And there's a lot of people that think that we may be able to predict BRD very early based on the microbiome signature of an individual animal. The problem is, what's one of the things we have to have for targeted metaphylaxis to work? It's got to be very rapid, right? Because if I'm working calves and I want to know, should I give this calf that just came in my chute Draxxin or not? I need to have an answer within 30 seconds probably, right? And this is a several day process. So the technology's not there yet. The concept is solid though. One thing we're looking at is the leukocyte profile. And I'll show you more on this here in a moment. But the white blood cells, the concentration or the count of white blood cells in the animal's blood may be able to predict or indicate whether they're normal or abnormal or at less risk or greater risk for BRD. And we're doing that with a machine called a Q-Scout BLD, where we take a small little blood sample from the jugular. We can take that in about 3 or 4 seconds once you get good at it. You drop a drop of blood in a card. You put the card in the machine and push play, and about 30 seconds later, the machine reads the blood count and gives you, based on an algorithm that the company's developed, tells you whether that animal is normal or abnormal with a green light or a red light, okay? How might you use that information chute side in a group of high-risk calves that you're deciding to give metaphylaxis to? Well, you may give metaphylaxis to the red lights, right? And not give metaphylaxis to the green lights, okay? And we've run about 1,500 head or so on this of high-risk calves through this machine, and about half of them come back with a green light, about half of them come back with a red light. And so if we were to implement this and it's effective, right, that's the other thing we have to determine. It has to be better than random, right? If it's completely inaccurate, it's not helping me. I might as well just give every other calf through the chute Draxxin. This needs to find the 50% that really are at greater risk, to where by cutting my metaphylactic drug in half, I still have the same level of health and performance had I given the entire group metaphylaxis, right? And so here's that process. So you take a quick blood sample. It's a special needle the company's developed. You pull out a slide, you put a drop of blood in the slide. You enter that animal's ID number because you need to track each animal individually. Push play. There's a high-tech camera inside the machine that reads the blood cell count. It's a dry slide and the blood spreads out. And in about 30 seconds, you get an answer. And we may be able to target metaphylaxis using this technology. There's some new technology as well that may help us to diagnose BRD, okay? Up to this point, I've been talking about what can we do at processing, right? to help us guide decisions of which animals may get antimicrobial metaphylaxis or not. Those animals are eventually turned out into the receiving pen, right? Or into the pasture, and BRD happens while they're out in the pen. And there's lots of ways to look at animal activity through new technology that may indicate if an animal's getting sick before we can actually visually see it. And that's what this study we did actually shows. This is the motion index, or how much the animal's moving around. And then this is how many days before the pen rider actually pulled that animal based on clinical illness. And we can see that these animals, their behavior starts to decline if they're sick with the gray bar versus controls that were never treated. The sick animals, their behavior starts to be reduced at least a few days before the pen rider is able to see it, okay? And so there's a lot of different technology that's able to track the behavior of animals continuously. This is the one we've been using a lot. It's an SCR tag. Allflex is making this tag. Merck Animal Health actually is a partner in it. And we're seeing some really interesting data from these tags in cattle that were never treated for BRD versus cattle that were a BRD case, and how much they're moving around from the time they arrive all the way out to 56 days after arrival. What happens? The cattle that are never treated for BRD, the black line, they move a lot more than the cattle that end up being a BRD case. This is across time here. Here's how cattle move around throughout the day in a circadian manner. So 4 in the morning, 6 in the morning, we feed cattle about right here. They start moving around a lot more. And then nighttime, they don't move around nearly as much. But throughout the day, the cattle that are healthy the whole receiving period move around significantly more than the cattle that are treated for BRD. You can also look at rumination minutes from these tags. How much time animals are typically sitting sternal recumbent and chewing their cud. And the tag's able to do that. It's kind of mind-blowing, right? How does an ear tag tell us rumination time? Well, there's a 3-axis accelerometer inside that tag, and the company has done the research to know exactly the position of that tag and how it moves around when an animal's ruminating and chewing, okay? And it documents the time that tag's moving in that position. And as you'd expect, when newly received calves arrive, they don't have very much rumination time. Why don't they have very much rumination time? They're not eating very much, right? And rumination and eating, how much they're eating is highly correlated, right? But then as they get up on feed, they start to ruminate quite a bit more. And here's how they ruminate throughout the day. So opposite of activity, basically, right? We feed them around in here. They're not ruminating. They're up at the bunk. They go get a drink of water and kind of mill around during the day. Most of their rumination occurs throughout the night. Here is rumen temperature. We can track rumen temperature, or there's other devices that can track temperature continuously that may be a tool. I use this to segue into the very last part of my talk that I'm about to get into to show this. We delay vaccinate all of our high-risk calves that arrive in our feedlot, okay? And we wait until day 28 to do that. Look what happened in this population, even at day 28, to the rumen temp. Pretty clear increase in temperature that's pretty much attributable to that MLV vaccine that we gave on day 28, okay? We'll talk more about that. All right, here's the last part of my talk. This was kind of discussed a little bit previously, but there's a lot of interest or attention on delaying the MLV vaccine in high-risk calves. And I will do my best to explain why this may be beneficial. Here is what veterinarians have recommended traditionally that we do in either high-risk cattle or low-risk cattle when they arrive in our feedlots. Or you could translate this to the stocker scenario too. Basically, every veterinarian, every consulting veterinarian surveyed in this survey recommended at least one of the antigens to give to high-risk cattle on arrival. And yet, if we read the label, and these are the old label claims, but this is what a vaccine label will say on it. Vaccinate prior to times of stress or exposure. Protect animals from exposure for at least 14 days after vaccination. And now that you guys, through a few talks, understand what these animals are going, these high-risk animals go through, do we follow these labels if we vaccinate on arrival or give them 24 hours rest? Not at all, right? And so we started to do research that looked at, should we be giving an MLV in the middle of all this stress and natural disease challenge, or should we delay it for some period of time to allow those animals to return to homeostasis, be out of their stress state, and hopefully be, for the most part, beyond the natural disease challenge, okay, that occurs in these calves. And so here's the very first study we did. There was a tendency, if you will, for the delayed group, and this is delayed only 14 days. 14 days is not long enough, I'll preface with that. But even if they were delayed 14 days, a tendency for less morbidity if we waited to give the MLV vaccine. And then average daily gain was significantly greater if we waited to give the MLV vaccine in high-risk calves. We followed up this study with a similar study and didn't have any statistical differences, but the numerical difference, you can see, was still there. Numerically less overall morbidity if we waited to give the MLV vaccine in high-risk calves, and average daily gain was basically the same in that study. Here's the third study we did. Delayed the MLV vaccine to day 14. This study, no real difference, a slight advantage actually on the on arrival, and then a slight advantage to the delayed on average daily gain in this study. And then we did a fourth study more recently, really no difference, 0.5% if it was delayed, slight advantage for gain if it was delayed. But Dr. Miles' group, and I think this was shown earlier, but Dr. Miles did a big large pen study looking at delaying vaccination. No difference in initial BRD morbidity, but a significant reduction if we delayed it to 30 days, a significant reduction in the number of cattle requiring 2 BRD treatments, a significant reduction in the retreatment rate, and then nearing significance for both BRD case fatality rate and the BRD mortality rate being advantageous to the delayed group. And this is delayed to 30 days on feed. And medium risk feedlot heifers, of which about a quarter of the population was treated for BRD. So why aren't vaccines working? Because the data I just showed you, it was either better, right, to delay, or it didn't matter. And when does BRD occur in these high-risk calves? It's occurring very early, right? And so if we're getting BRD outbreak on day 4, 5, 6, 7, 8, 9, 10, and we delay the vaccine to day 14 or day 30, we have a negative control group during that time that never got a vaccine. And if that vaccine was efficacious, the on-arrival group that gets it right when they get there, if that vaccine was changing outcome in these cattle, we would expect a significant improvement for the on-arrival group, right? Okay? But the data shows that it either doesn't matter if you vaccinate or there's a slight improvement if we actually delay it, okay? And it has nothing to do, in my opinion, with how the cattle respond to the vaccine. It has to do about timing. How long does it take for antibodies to be produced against the MLV vaccine when given to a bovine? At least 2 weeks before protective antibodies, oftentimes longer, depending on the antigen. And so the timing is wrong, for one. We get a lot of morbidity within the first 14 days, right? When even if we vaccinate right here, we don't have protective antibody until day 21. Okay, this is a typical antibody response. This is against IVR virus. A lot of these calves are showing up with virus. Okay, not a lot, but you can see the prevalence rate here. This is from 4 different truckloads, and we took nasal swabs and ran those swabs in the lab to determine if there was virus present in the nasal swab, okay, on high-risk newly received calves at the day of processing. And in every truckload, at least one animal, except a couple here for BVD, at least one animal was shedding at least one of the viruses that we vaccinate against. And there's quite a bit of evidence that if you vaccinate with an MLV on top of a natural wild type infection with a virus, you make the outcome worse. Okay, it's synergistic. BVD 0, 1. This would suggest BVD is not very common, right? But I think it was talked about earlier. PIs are the major reservoir, and we didn't have any PI calves in this truck. I think we did in 1. Why else don't vaccines work? Well, the antigens, although they are attenuated, that means they're weakened, right, to where hopefully they're not as virulent and cause disease. But if you administer a live replicating antigen to an animal that is highly immunosuppressed, and that live antigen in that 2 milliliter dose is live virus, what does virus try to do when you inject that in the neck of the animal? That virus is trying to get in that animal's cells and replicate. That's what virus does, okay? If that animal has a suppressed immune system and can't keep that vaccine virus in check from replicating, what's going to happen? You're going to get 5x, 10x, however many x more virus replication from that MLV antigen that's in that little 2 milliliter dose, and it's going to essentially over-replicate in the animal, okay? Safety concerns. Also, in stressed cattle. These cattle were stressed, or these cattle were not stressed. These cattle were stressed for 1 day. These cattle were stressed for 3 days. This is the percentage, 67%, 56%, none, 100%. That's the percent of cattle that were shedding virus from the vaccine that we gave them on day 0. And so if they're stressed, they're much more likely to be shedding IVR, BVD, BRSV from the vaccine than if they're not stressed. See, 67% of them on day 14 were shedding IVR virus versus only 9 or 10% in the non-stress group or the group only stressed for a day. Delaying vaccination has nothing to do with improving the vaccine response. In those studies I showed you, in a couple of them, we actually measured antibody titer from those. In the calves that we gave the vaccine, the MLV vaccine, on day 0, when theoretically there was more stress, they responded to the vaccine just as well in one study and an even greater antibody response in the other study versus the group that was delayed. and under less stress when they got that initial MLV vaccine. And that's because that vaccine just over replicates, right? And eventually that animal comes out of stress and its immune system sees all that virus and produces quite a bit more antibody in response to the greater antigenic load when that live virus is given to an immunosuppressed animal.